Hello, my dear student. Today we will talk about natural numbers. Natural numbers start from 0 and go on to infinity. Negative numbers are not included in natural numbers. In natural numbers, fractional numbers and rational numbers are not included. Natural numbers, you see, such as start from 0, 1, 2, 3, like 4, is a set of numbers that goes on to infinity like this. Now, you should pay attention to this. With place value, you shouldn't confuse number value with place value. Place value means something different. Number value means the digit itself. Let's do an example here. Now, our number is 9785. Let's find its place values. Look, this is the ones place. This is the tens place. This is the hundreds place. This is the thousands place. Discussing place value, you multiply the digit by the place value. You're multiplying by the place value. Here is the place value. You're multiplying the digit here by the place value. There you have the place value. You're multiplying the digit here by the place value. There you have the place value. Again, you're essentially multiplying the digit here by the specific place value. There you have the place value. So what do these things we found become? Place value. It becomes. Now, what does digit value mean? It means the same thing as number value. Let me show you this with an example. When it says to find the digit value, it actually wants you to find the digit. Now, in the example, our number is 29,873, 29,1873. Here, the digit in the ones place is 3, right? That's the digit value as well. Got it. So, the digit value is also 3. Is that understood? Let me write it down like this. Saying digit value means the same as number value. Its digit value, that is the number value, is 7. 7. Its digit value, that is the number value, is 8. Its digit value, that is the number value, is 9. Its digit value, that is the number value, is 2. The number value and the digit value are the same thing. Don't forget this. I'm writing an example. 1256, a 4-digit number. Now heed attention. This is the hundreds place. I did this. When I add 3, I mean when I increase the digit 5 here by 3, the result of the number doesn't increase by 3. It grows by value of the place. Look. This is the ones place, this is the tens place, this is the hundreds place, and this is the thousands place. So how much does this number increase? Look, if you multiply by 3%, it would have increased by 300. Or if you reduce the digit here, for example, our number is 2,576. If you reduce the digit here by 2, when you reduce it by 2, the number decreases by 20. As it increases here, it decreases there. Why did it decrease by 20? Because this is the ones place, and this is the tens place. 10 times 2, it has decreased by 20. We pay attention to this. Now, let's solve another example question. They've given us a 5-digit number. You need to look carefully. The place value of the hundreds place. So, where is the hundreds place? First, let's write the number here. Yes, we've written our number. The ones place, the tens place, the hundreds place. The place value of the hundreds place, we find this place value by multiplying the digit here by 100. What does this do? 100. So, the numerical value of the tens place The tens place, the ones, the tens. The digit in the tens place is 2. When we say numerical value, we mean itself. This is 20 times 2. 20 times 2. When we say 20 times, we multiply by 20. What did it do? 40. Yes. The total of these is 240. So, the sum of this and this, let's write it here. 100a plus 40 equals 240. What doing to us? Sir, they're asking about a. This is 40% of the equation. I'm moving it to the right side. The sign will change. 100 times a will be 240 minus 40 from here. 100 times a. 200. Both sides. I'm over 100. These have been simplified. The value of a was found to be 2. So we say that indeed the value of a is 2. Let's take a look at our example. Here, it is given a 6-digit natural number in the thousands place. Now let's take the number here. Yes. Now, the thousands place, units, tens, hundreds, thousands. This is the thousands place. The numerical value of the digit in the thousands place is double. The numerical value means itself. Doubling means to multiply by 2. Yes, this. The numerical value of the digit in the tens place is 3 times the tens place. Units, tens. This numerical value means b. 3 times is 3b. The sum of these is 14. And I'm adding it to 14. The question also provided me with an additional equation to use. Writing down, yes, let's write it like this. A minus b equals negative 3. It's asking me for b. Now I need to get rid of the a here. I need to eliminate. That's why I simply need to equal the coefficients. And the sign needs to be opposite, because opposite signs will cancel each other out. That's why I'm precisely multiplying this by negative 2 instead of exactly 2. I'm writing other equation as it is. SUA plus 3b equals 14. When I multiply it by negative 2, I get negative 2a. The product of negative and negative gives me positive 2b. When I multiply negative 2 by negative 3, I get positive 6. Now I'm currently doing the addition. Plus 2a and minus 2a cancel each other out. When I add 3b and 2b, I get 5b. When I added this up, it made 20. Since I want to find b, and this is in the multiplication case, a multiplication expression is not thrown across. However, it counts as division. I'm dividing this by 5. I'm dividing this by 5. And from here, I'm actually saying I found b to be 4. Now let's talk about the analysis of natural numbers. If we break down the number 23, here's how I write it. 23 is 20 plus 3. I also multiply that 20 by 10. Why am I multiplying by 10? Because this is the units place and this is the tens place. 10 times 2. We'll also multiply 3 by 1, but we don't write 1 as it doesn't have an effect. This is how we find it. So how do we define the breakdown of the number AB? Like this. When breaking down the number AB, I can write the units and tens as 10 times A and B. So 1B and B are the same thing. Looking at the other example, if we break down the 3-digit number 345, we have 3 hundreds, which is 300, 4 tens, which is 40, and 5 ones, which is 5. This is 3 times 100. This is 10 times 4, and this is 5 times 1. It's okay we don't write 1. So we can express the breakdown of the number ABC like this. Units. Tens, when I say hundreds, while breaking it down, it's like this. 100 times approximately 10 times B and 1 times C. You don't need to write 1. We can express this like this. Let's solve the question here. AB and BA are both two-digit natural numbers. If the sum of AB and BA is 1 to 32, what is the largest value that the number AB can take? Now I want to share a secret with you. It's a two-digit number within a question. If words 3 digits are mentioned, you'll think of breaking it down. As 2 digits is mentioned here, I want to break it down right away. That's the secret. Since the term 2-digit is mentioned here, I want to break it down right away. Note the question. U E 132. Now, when we break this down, how are we going to write it? This is the units place, and this is the tens place. Tene plus no. While doing this, I wrote it as 10B plus A. 132. Now pay attention. Here, there are 10 of A. There is 1A here. 10 A's and 1A here. 11 A's. Then B, 1B. Then B. That equals, what is? Pay attention. Here it's 11, and here it's also 11. Both are common. When you take out the common factor, you write it as 11A plus B. 132. Now I want to show you a shortcut. To find the sum of AB here, you divide both sides by 11. Divide by 11. Didn't divide 11. If you don't see the middle one in the 3-digit numbers, you'll see that the result is 12. So from here, you can write A and B equal to 12. Now this is a digit and this is a digit. Since we are talking about digits, what can't we do? We can't go beyond 9. So I can write the largest number here as 9. It can't be 12, so I can write 3 here. So I would see that the largest AB number I can get is 93. Now, why? 11, for example, look at 11. Think that I multiplied by 15. This is 5 at the beginning and 1 at the end, and the sum of 5 is 6. Look like this, or 11. Let's think that I multiplied by 24. 2 start, 4 finish, and the sum of 2 and 4 in the middle. While dividing these, let's say, for example, 264. Divide by 11. Look, we don't see the middle because the sum of 2 and 4 gives us the middle. We say that the result of the division comes out like this. Now, let's move on to the next exercise. Let's take a look at this question. AB and BA are both two-digit natural numbers. An equation has been given. What is the smallest value that the number AB can take? It asks. Now, look again. The term two-digit has come up. When we say two-digit, three-digit, four-digit, we should think about analysis. First, I'm moving these unknowns to one side of the equation. I'm moving this to this side. So, I've written AB. This BA will go to the left side of the equation as negative BA. That's also 36. Now you need to pay attention. I'm doing the analysis. A plus B. Pay attention this. There's negativity here. Since it's negative, you need to open the parentheses. Chimbe plus Jena plus A. You need to open the parentheses for negatives. Addition, that equals Tishiki. Now pay attention. I'm writing this down. 10A plus B. I'm distributing the negative. Negative, 10B. Pay attention to this. Multiplying negative and positive. Negative A also equals 36. Now, here, there are 10 A's. There's 1A here, but it's negative 1A. 1A came out of 10 A's, 9 A's. Now pay attention to this. 1B, 10B. Look, 10 B's are coming out of 1B. So that's negative. That also equals 36. Now I see that the 9s are common here. And when I take the 9 out of the parentheses, a minus b equals 36. Now what do I multiply by 9 to get 36? Of course 4. 9 times 4 is 36. I'm writing here now a minus b equals 4. We're not forgetting that both a and b are digits. Now, it has asked us for the smallest value of this. So what is the smallest digit I can use? For example, if I use 4 for this and 0 for that, 4 minus 0 is 4. But look, here b can't take the value of 0. Why can't it? Because look, b has come to the front here. The numbers that come at the front can't take the value of 0. Then if I give this 5, if this is 4, I can give this a 1. Yes, 5 minus 1 equals 4. So the smallest AB number I will obtain is found to be 51. It says the correct answer is option C. Now let's take a look at this example. It's a very nice question. A and B are each a digit. When it says digit, we will know that we won't exceed 9. It says that there is also an R number for K. What does R number mean? There are all kinds of numbers. There are negatives, there are positives. There are fractional numbers, decimal numbers. Now it has simply given us a pair and is asking us about it. We will start from the request. Look, now it has given K times AB. Pay attention. Here, A and B, you know, is a 2-digit number. If we analyze this, K will be in the form of 10A plus B. What do I get when I distribute this K inside the parentheses? Look carefully. 10 times K times A plus, again K times B. K times B. Now I want you to pay attention to this. Has it given us this? It has given K times A. Look, times K is 18. I want you to know this. Saying A times K is the same as K times A. Then I'm writing 18 here. This has also been given here as 30. After this, getting to the result is very easy. When I multiply 10 by 18, I get 180. From here, when I add 30, I find the result to be 210. Move on to the next example. Let's move to our example. Let's look at the question. AB and BA are 2-digit natural numbers, and an equation has been given. And it tells us the sum of the possible values that the number AB can take. So how are we going to do this? We're looking carefully. Now, since it says 2-digit, I need to analyze it again. When I analyze this, I can write it like this. Right. After that, when I analyze this, I can also write it like this. I can write it like this. I move to this side of the equation. I'm distributing the 5 into the parentheses. 5a plus 5b plus 54. Now I want you to pay close attention to this. 10 A's, 1 A, 11 A's, and 10 B's, 11 B's. That's equal. Approximately 5 A's, 5 B's, and 54. Now let's move these 5 A's over here. When I move the 5 B's over here, they'll come in as negative. When 5 A's are taken from 11 A's, there will be 6 A's and 6 B's left. Here there is 54. Now when I take this back into parentheses of 6A and B, equals 54. From here I see that the sum of A and B is 9, because 6 times 9 is 54. So then, when I write it like this, the sum of the 2 digits AB needs to be 9. Which numbers do I need to add to get 9? If I add 8 and 1, I can't give 0 because 0 can't be at the beginning. 8 plus 1, similarly 7 plus 2. Ladies, 6 plus 3, 6 plus 3, 5 and 4, 5 and 4. We can also write these by switching their places. 4 and 5, ladies and gentlemen, 3 and 6. Then 2 and 7, 1 and 8, like this. This takes the values of AB. So when we add up all the values that AB can take, we find that the total is 386. Our correct answer is option D. That's a nice question. Let's read. AB and CD are each a two-digit natural number. Two equations have been given for us to use. Pay attention to what it asks us. The expression it asks us, sir, with the EU, brother and sir, 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 brother and sir. It's asking us for the result of the multiplication of CD. So how do we normally multiply these? That's how we multiply, right? We write them one below the other and we perform the multiplication this way. Pay attention. What will I get when I multiply it with AB? I'm looking given to me D. When I multiply it with AB, I will get this D. The product of D and AB here is 148. Again, when I simply multiply C with AB, I get 185. Of course, we slide it like this. And after simply adding this, we clearly observe that the answer is 1998. Let's move on to our next exercise, our example. When we look at the question, AA is a two-digit number. An equation is given. It says it's a natural number, and an equation is given. It's asking what A is. Again, when it says two-digit, analysis will come to my mind. Then I will first write down what has been given to me. A times A equals 1 to 76. Here, AA, since it's a two-digit number, I'm doing an analysis. How? 10 plus 1A multiply by outside A equals, now pay attention to the part 10A plus 1 more A. 11A times A equals 1 to 76. Now, this 11A means the product of 11 and A. And A's product is a squared. 11 times a squared equals 176. Now look, when I divide by 11 to find A, I had shown a tactic with 11 before. Look, the sum of 1 and 6 gives the middle value. So when I divide by 11, it's enough to just erase the middle. The answer will be 16. So what is a squared equal to? 16. Now A can also be 4. Of course, it can be negative 4. But we know that A is a number. Numbers cannot be negative. So our answer is 4. We say the correct option is option D. Let's move on to the next exercise. Let's take a look at example. In this example, let's read in the three-digit number ABC. Let's write it here. In the three-digit number ABC, the digit A is increased by 2. So the digit here will increase by 2. Increasing the digit by 2 means that this number will increase by 200. Digit B will be reduced. The digit B will be decreased by 3. Since this is the tens place, the number will decrease by 30. As a result, it will increase by 170. It means that the result will increase by 170. We say the correct answer is option A. I definitely hope to see you in our next lesson. Don't forget to subscribe, follow, and turn on the notification bell. Hope to see you again. Looking to seeing you.